Welcome to Brain Vision.
For this problem on the topic of equilibrium of a particle, we are given a lamp of 20 kg supported by multiple cords, each with a different tension. We want to determine the tension developed in each cord, which is required to keep the system in equilibrium. Now we'll apply the equations of equilibrium along the x and y axes to the free body diagram, firstly of joint D, which we have in figure A. So for joint D, we'll take first the right direction to be positive and take the sum of all the forces in the horizontal direction. These must equal to 0 since the system is in equilibrium. And this tells us that F dE times the sine of 30 degrees minus 20 into 9.81 is equal to 0. So this is actually our y component and not our x components. So we take upward to be positive, and we take the sum of the y components, and this is the equation that gets set up. So we have FDE sine of 30 degrees minus the weight of the lamp 20 times 9.81 is equal to 0, which means we can immediately find this tension FDE. And FDE from here we can see is 392.4 newtons. Keeping our significant figures, this is 392 newtons. So we found the first tension. Next, we'll take the right direction to be positive and take the x components of all the forces and sum them together. The sum should be 0 again. Again, there's no net motion in the horizontal direction. So this is 392.4 times the cosine of 30 degrees minus FCD. That must equal to 0, which means now we can find FCD immediately, and we get the tension FCD to be 339.83 newtons. Again, keeping our significant figures, this is 340 newtons. So we found the second tension as required. Now, using the result for FCD of 339.83 newtons, and again we'll apply the equations of equilibrium along the x and y axes, but this time to the free body diagram of joint D. So for joint D, we have, again, if we take the right direction as positive, and we take the sum of the forces along the x direction, this must equal to 0. Which means 339.83 minus FCA times 3/5 minus FCD times the cosine of 45 degrees is equal to 0. Now we'll call this equation 1. If we take vertical components with upward to be positive and sum them for all the forces, again this must be 0, and this is FCA times 4/5 minus FCB sine of 45 degrees, and again this must equal to 0. So we'll call this equation 2. Now we can solve equations 1 and 2 immediately, and we get, or simultaneously rather, and we get firstly FCB to be 275 newtons, and then the tension FCA to be 243 newtons.